Hi, I'm Bobby Russell, and I'm a Microsoft Technical Trainer. I'm here to walk you through the SC-200 Microsoft Security Operations Analyst course. Welcome to Learning Path 6. In here, we're going to create queries for Microsoft Sentinel using KQL, or Kusto Query Language. In this learning path, we're going to cover how to construct a KQL statement. We'll look at analyzing the results from using KQL. We're going to look at building multi-table statements using KQL. And finally, working with string data when we're creating and using KQL statements. So let's dive right into our first module, which is constructing KQL statements for Microsoft Sentinel. After completing this first module, you'll be able to construct a KQL statement, search log files for security events using KQL. You'll be able to filter searches based on event, time, severity, domain, and other relevant data using KQL. KQL, or Kusto Query Language, is important because it helps you quickly search, analyze, and visualize large data sets, especially in tools like Microsoft Sentinel or Azure Monitor. It's designed to be readable and efficient, so even complex queries can be written and understood easily. If you're working with logs or telemetry data, KQL is like having a superpower for spotting trends, detecting issues, or investigating incidents fast. In this image, the structure of KQL is defined. It emphasizes its data flow model, where each operator processes and passes data to the next stage. The example query filters the security event logs for event ID 4626. It then summarizes the count of the events by account and limits the output to the top 10 results. KQL is optimized for log and telemetry analysis, making it ideal for scenarios like threat detection, performance monitoring, and incident investigation. The query is broken up into three logical phases. You have the filtering and preparing of the data, you have the applying analytical conditions, and then finally, preparing evidence for decision making. By using a readable and modular syntax, KQL enables analysts to build complex queries incrementally and automate insights across very large data sets. Most KQL queries you'll write are tabular expression statements, which just means they take in tables and return tables. These queries are built using what's called operators. Each one takes a table, does something with it like filtering or summarizing, and then passes the result to the next operator. You chain these operators together using the pipe symbol, so the data flows step by step, getting shaped and refined along its way. So the search operator in KQL is like a quick scan. It looks across all columns and all tables for the keyword or phrase you give it. It's super handy when you're not sure where the data lives or what field it might be in. Think of it as a broad net that's used to cast and catch anything relevant before narrowing things down to be more specific with one of your other filters. It's especially useful in early stages of investigations, like when you're hunting for signs of suspicious activity across multiple logs. The where operator is your go-to filtering for data. It lets you narrow down results based on specific conditions. It's like saying, only show me the rows where this thing is true, whether it's a certain event ID, username, or time range. You usually use it early in your query to cut out the noise and to focus on what really matters. Compared to search, where is more efficient because it targets specific fields instead of scanning everything. The let operator is like a shortcut. It lets you define a variable or expression once, and then you can reuse it throughout your query. It's super helpful for keeping your queries clean, especially when you're working with long filters or repeated logic. You can use the let to store things like time ranges, calculated values, or even subqueries. It makes your queries easier to read and maintain, especially when you're collaborating with others. Another operator we have is the extend operator. The extend operator lets you add new columns to your data set by calculating values on the fly, kind of like creating a custom field in Excel. It's perfect when you want to transform or extract part of your field, like pulling the domain name from an email address or the directory from a file path. This simple query starts by pulling data from the security event table in our example here, focusing only on the events from the past hour using the ago function. It then filters out any rows where process name or process fields are empty, which helps clean up the data set before we do any further analysis. The extend operator is used to create a new column called start_dir, which is derived from trimming the process part from the full process name. This kind of transformation is useful when you want to isolate the directory path from a full executable path for further grouping or investigation. Overall, the query is a great example of how KQL can be used to filter, clean, and reshape data in just a few lines. The order operator lets you sort your results, either ascending or descending, based on one or more columns. It's super helpful when you want to bring things from the most recent or the least recent events to the top. So in this example query, the query starts by pulling the security event data from the last hour and filters out any rows where process name or process are empty. It uses the extend operator to create a new column called start_dir, which trims the process portion from the end of the process name. The order by operator is then used to sort the results first by the start_dir in descending order and then by process in ascending order. This kind of sorting is useful when you want to group similar directory paths together while still keeping the process names in a readable order. Overall, this shows you how you can combine filtering, transformation, and sorting to shape your data for cleaner insights. The project operator is your go-to when you want to pick and choose which columns to include in your results, like customizing your own view of the data. You can also rename columns. If you want to rearrange the order of the columns, just list them in the order you want using the project-reorder operator. They'll show up exactly the way you want in the results. If you ever want to exclude just a few columns instead of listing everything that you want, there's a sibling operator called project-away. And that does exactly that. It only shows you the columns that you want and removes the other ones. So now, let's jump into our second module, which is analyzing query results using KQL. After completing this module, you'll be able to use the summarized data statements. You'll be able to render visualizations using KQL statements. So continuing on with our operator discussion, now we have the summarize operator. The summarize operator is a go-to when you want to group data and calculate things like counts or averages or maximum or minimal values, kind of like a pivot table in Excel. After summarizing, it's super common to use the project command to clean up the output, maybe to rename columns or just show the ones you care about. For example, you might summarize login events by username and then use the project to rename the count column to something like login attempts. Together, summarize and project give you a powerful way to analyze trends and present clean and focused results. So in the example we see here, the first query pulls data from the security event table and filters it to only include events that happened within the last hour. It then uses summarize dcount IP address to count the number of distinct IP addresses seen in that time frame. This is useful for looking for things like unusual spikes in activity. The second query works with the sign-in log table. It defines two variables here: the time frame, which is set to 30 days, and the threshold, which is set to 1. It filters the sign-in attempts with the result invalid password within the last 30 days. Then it summarizes how many unique applications were accessed per user and IP address. And then finally, It filters to show only those that have at least one unique application, which could help identify suspicious login behavior. Here we have another example of using the summarize operator. So the first query uses the argmax time generated command to return the latest events to the computer. The computer we're looking for is sql10.na.contosohotels.com, along with all other columns from that row. The second query does the opposite. It uses the argmin for the time generated. And this is going to return the earliest event for the same computer. The argmax and argmin functions are super useful when you want to grab the full row of data associated with maybe the first occurrence or the last occurrence for something. Both queries group the results by computer, which means if you had multiple computers, you'd get one row per computer showing either the first or the last event. This is a great technique for tracking changes over time, like identifying when a system first or last reported a specific type of event. And finally, one more example of using the summarize operator. In this example, both queries filter the security event table for event ID 4624, which typically represents a successful login event. And we're looking for this occurrence within the last hour. The first query uses the make list term to return all account names associated with each computer. Now here's the important part. It includes all duplicates. So if a user logged in multiple times, their name would appear multiple times in the list. Now in the second query, we use the make set command, which returns only unique account names per computer. So this removes all the duplicates. Both queries group the results by computer, so you get one row per computer showing either a full list or a unique set of accounts that logged in. Our next operator is the render operator. The render operator in KQL is used to return query results in visualizations like charts or graphs, which are perfect for things like dashboards or if you need to get quick insights. The first query filters events for the past hour in our example. It counts how many events are associated with each account and then uses the render bar chart command to display the results in a bar chart. This is great for quickly seeing which accounts have been most active. The second query also looks at events from the past hour, but groups them in the 1-minute intervals using the bin time generated 1-minute command. It then counts the number of events in each time slice and uses render time chart command to show how activity changes over time. Both queries use summarize count to aggregate the data, but they focus on different dimensions, one by account and the other by time. The render operator is what turns a query result into visual charts, making it easier to spot trends or even anomalies at a glance. So now, let's jump into our third model here, which is building multi-table statements using KQL. After completing this module, you'll be able to create queries using the union to merge results from multiple tables, and also merge tables with the join operator. So let's get into the union operator. The union operator in KQL is used to combine the results of two or more queries into a single data set. Think of it as like stacking tables. Union takes the output from multiple queries or tables and then takes that and merges them together into one big rule set. It's great for comparing or aggregating data from different sources, like combining a security event log with a sign-in log to get a fuller picture of the activity. The join operator in KQL is used to combine rows from two data sets based on a common field. Kind of like a VLOOKUP in Excel or a SQL join statement. In the example you see here, the query uses the join operator in KQL to correlate log on and log off events by account. Here's a breakdown of what's happening with this example here. The first part, the left side of the join, it filters the security event table for event ID 4624, which represents successful login events. It then summarizes the number of login events per count using the count field. It keeps only the logon count and account columns. The second part, or the right side of your join, here it filters event ID 4634, which represents log-off events. It summarizes the number of log-offs per account and again keeps only the log-off account and account columns. The join operation. So with this, the two datasets are joined using an inner join on the account field. This means only accounts that have both log on and log off events will appear in the final result. So what's the final output? The result shows each account along with how many times they've logged on and logged off, which is useful for identifying session activity or spotting maybe anomalies, like accounts that log on but never log off. Now there are some join flavors. Join flavors define how rows from the left and the right tables are matched and included in the final result. Common join types include the inner join, which only includes rows where both tables match. The left outer join, which includes only rows from the left table and the matching tables from the right. The right outer includes all rows from the right table and the ones on the left table that match. Full outer includes all rows from both tables with nulls where there is no match. Then we have inner unique. Like inner, but it assumes the right side has unique keys. Choosing the right join flavor depends on your goal, whether you're enriching data, filtering it, or ensuring completeness. Let's jump into our third module, working with string data using KQL statements. Now, after completing this module, you'll be able to extract data from unstructured string fields using KQL, and you'll be able to extract data from structured string data using KQL, and finally, creating functions within KQL. So let's look at another operator, the extract operator. The extract operator is your go-to when you need to pull specific pieces of text out of a string using regular expressions. It's super handy for things like grabbing IP addresses or username or file paths from log messages that are all bundled into one field. You just give it a regular expression pattern and tell it which capture group you want. It does the rest. It's especially useful when your data isn't neatly structured and you need to break it down into usable parts. Think of the extract as your digital scalpel. It slices out exactly what you need from the messy text. Then we have the parse operator. The parse operator is like a smart template. It lets you break apart a string into separate fields using a pattern you define. It's perfect when your data is semi-structured, like maybe log messages that follow a very consistent format, but aren't in nice, neat columns. It's a bit more readable than using regular expressions, especially when you know the structure of the text you're working with. Think of a parse as a cleaner, more intuitive way to extract data when you already have good ideas of the format that you're dealing with. So here's an example. This demonstrates how to integrate external data into KQL string using the external data operator. Here's a breakdown of what's happening in this example here. So we have a data source. It pulls in a list of user IDs from an external file, users.txt, which is stored in an Azure Blob storage account. Then we have the access. The file is accessed using a secure URL that includes a SAS token which grants temporary secure access to the blob. Then we have our integration. The external data operator reads the file and treats it like a virtual table with a single column, user ID or of type string. Our filtering. The main user's table is then filtered to include only those rows where the user ID matches one from an external list. Then we have our use case. This is useful when you want to cross-reference internal logs with an external list, like a watch list or a VIP user list or known threat actors, without importing the list into your main data store. So this demonstrates how to create and use a function in KQL to simplify and reuse a query. Here's what it's doing. The first part of the query is the filter, and it's filtering the security event table for event IDs where the event ID is 4672. The comment suggests saving this query as a function named privlogins. The last line, privlogins, shows how you would call that function later, just like referencing a sample query. It returns the same filtered results without rewriting the logic. This approach is great for modernizing your queries, and it also improves readability and maintainability, since you can update the function in one place and have it reflected everywhere it's used. All right, so we've talked a lot about KQL here, and this lab demonstration for this learning path is a great way for you to see these commands in action. I'd highly recommend that you review it. In this lab demonstration, we will walk through a series of Kusto Query Language or KQL queries, and we'll discuss each of the queries and give you an idea of exactly what they're doing. So in my environment here, I'm using a demo environment, which has a lot of different tables within here. So you can see there's most of our queries will be with the security event table here. So if you have one of those tables, you can follow along with these queries if you so choose. So let's go ahead and get started here. And in our example here, the very first query that we're going to run will be just a generic query. And in this query, we're going to look at the security event table itself. So we're going to do a security event, and we're going to go ahead and run that here. And there we go. So as you can see, here's an example of that. Now, the nice thing about running a query just from the table itself is you get everything within that table. But the downside to running this query is the fact that you get everything within that table. And if it's a very large table with a lot of data in it, then you may get too much, it may become unusable. So it's better to filter whenever possible to run these queries. But that there gives you an example of running a basic query just on the table itself. So now what we're going to do is we're going to look at another query here. So in this query, what we're going to do is we're going to run the search in. So we're going to do a search, which is an operator, and we're going to look in. So if you notice here, it says in. We're going to look in the security event table and any table that starts with APP. And what we're looking for here is we're basically looking for anything new. So that's what we're looking for as far as that query is concerned. If you notice here, you'll see a lot of results that have been generated here based off of that. So that's another example of doing a query where you perform a search operation. Now, to give you another example of a query, what we're going to do in this scenario, now we're going to start seeing a little bit more, I don't want to say complicated, but more involved queries. So in this example, we're looking at the security event table, and within the security event table, we're looking for anything that's basically happened within the past 7 days. And as you can see here in my output, there's quite a few entries that have been generated based off of that. So the where operator essentially is a filter that you can use. Now, we're going to take this a step further. And now what we're going to do is we're going to say, okay, we're going to look at the security event table again. But in this case, we're going to look for similar to what we just had within the last 7 days. And notice here, the double equal means we're looking for an event ID that's specific. And the specific event ID is 4624. So that's what we're running in this case. So let's go ahead and generate that query. So as you can see here, it did not find anything. But again, in the real world, you would go in and you can manipulate the time frame a little bit, or maybe the event ID. Let's run this one more time just to make sure, to see if we can get anything. Now, there's an easy way to do this. I can go in and I say, okay, we're going to keep the time generated within the last 24 hours. If I wanted to, I could go in and say, I could remove the time generated and just leave the event ID to get that information. But in the last 7 days in my lab environment, there have no entries been created in the security event table specifically related to event ID 4624 as part of that. So let's go ahead and run another query. And in this query, what we're going to do is we're going to look at the security event table. Within the security event table, we're going to look for, again, our time generated here. So we're looking within the last 7 days. We're looking for event ID 4624. And we're looking for anything related to, in this case, where the account type is user. So let's go ahead and run that query. And again, nothing was generated. So here's what we can do to play around with this a little bit. We do have the ability, let's go ahead and remove the timestamp, because one thing, before I do that, let me point out something. Notice here, when you have a time-related query within your query field itself, the time range up here changes to set in query, because you can either have it in your command or you can have it up here. But if I remove this, you'll see that now I have the ability to go in there and rerun this, and I can manipulate the time from here. So let's go ahead and play with this. Let's go back a few months here and let's rerun it, and it will generate some output. So you can see here, in this case, we're looking in my security event table. I'm looking for event ID 4624, which, if you notice here, is event ID 4624. So I'm filtering based off of that, and anything related to user activities. If I scroll across, I'll see some user activity stuff related to that. So that's another example of where you can do that. Now, keep in mind, the where statement is going to be one of your very popular statements, operators that you're going to use, because it's your filter. You typically are looking for specific things, so you want to be able to filter versus getting just everything that's within your table. Another example would be, in this example here, using the let operator. The let operator is basically a variable statement, is essentially what it is. So in this case here, what we're doing, we're going in and saying, we're going to say, okay, the time offset command, wherever that is in the query, which it happens to be wherever it is in the query, which you'll see it right there, whenever you see that, replace it with 1 hour. So basically, when the command is run, this is going to be replaced with 1 hour. And then we also said, you know what? For discarded event ID, wherever that shows up in our query, which it shows up right there, replace it with 4688. So that's what this is doing in this example. So we're adding variables. And the reason this is useful is because if you build a query and you like it and you want to run it multiple times, maybe with different data points, maybe I don't want event ID 4688. Maybe I want event ID 1234, whatever it may be, then I can save this, and all I have to do is change this variable here to whatever number I want and keep the query the way it is. And I can always rerun it. Same thing here. I can always, if I want to do, instead of 1 hour, I want to do 5 hours, I can change it in one place and it'll update my entire query. So that's the benefit of doing that there. Now, what we're doing now is we're saying, okay, we're looking for, in this table, where the time generated was between my time offset times 2. So my time offset is 1 hour. So we're looking at 2 hours ago times 2. So 1 times 2 is 2. So we're looking for anything that happened between 2 hours ago and then the time offset, which is 1 hour. So between here and here. So between 1 and 2 hours, we're looking for event ID 4688. So that's what we're doing in this query. And again, notice if I run this here, I don't have any results, but if I go in and I change this a little bit here, let's go back here and run this. And we'd have to get rid of our time generated here to get that. Then, so let's remove this. And in this case here, it's not going to show me anything in between 1 and 2 hours ago. But just to give you an example of the output that you would get in this case here. So we're looking for an event ID that is not equal to discarded event ID. So we're looking for any event ID that is not 4688 as part of this. So it's going to show me everything else except for that event ID. And there's a column in here for my event ID where I would be able to see that there. So that's another example of a query that you can do within here. So now let's take a look at another example. So in this scenario, we're still using a variable option. So in this case here, our variable is going to be a little bit more complicated versus the one we had previously. In the previous example, we just put in a value. It was very easy. But in this case, we're going to have it calculated for us. So let low activity accounts, which is right there. So let this equal to the content of my security event table. And then what we're going to do is we're going to do a summarize. So what we're doing here is this is going to count the number of events for each unique account. So we're going to count the amount of unique events by account in the security event table. And then the results of that, of the two count and count, are going to be then generated. So where the count is, we're going to say a filter where any of our counts were based off of this here. So we're looking for fewer than 1,000 activities that occurred in here. So, or low activity accounts. Now, so that is the statement that we're using when we run the query. So we're looking for this right here, which is essentially this. And we're going to filter based on any account that contains SQL. Now, keep in mind, KQL is a very case-sensitive language. So you have to make sure if I do capital S or if I capitalize something somewhere where it shouldn't be, then I will get an error in my generation of my data. All right, so that's an example of creating a little bit more complicated variable in this case. So in our next one, what we're going to do is we're going to, again, look at our security event table. We're looking at that for any events that have occurred in the last 7 days, so seven days or less, where, and this is where we start getting a little bit, I like to say, fancier in this. So what we're going to do is we're going to extract data. And we're going to extract data to exclude rows where process name. So anywhere where process name or process, notice here the double quotes with nothing in there. So we're going to exclude anything with those areas where they're blank, where they're empty. So we're going to exclude that. And then what we're doing is we're using the extend operator, which you see right here. And what this is going to do is it's going to create a brand new column called starting directory. And in here, it's going to extract the starting directory path from the full process name by removing the process part at the end. So that's what this is going to do right there. And then what it does after that is it's going to generate an output. And the output or the results of this query, we're going to first start with the starting directory. So we're going to order it based on the starting directory descending. So Z to A, okay? And then the process, in this case here, we're going to look at process, and we're going to do that ascending, which would be A to Z. So that is the query. Let's go ahead and run it here. And I have no results. Again, it's because of my time frame. So let's remove the time. And let's go in here and create a custom one. Let's go back a few months here and run it. And here you go. So now we've got the output, which is going to be first ordered by our starting directory, and then by our process ASC, which is further down in our, if you scroll across here, you would see that in there. So that's going to be the output of what we have. And of course, anything with that's an empty field has been blocked as part of our example here. So if I go across here, there we go. So it identifies the process, which is right here. So it's a TI worker process. And this is going to be ascending. So it's going to be from
A to Z in this case, whereas our start dir was descending from Z to A. So now you can see the results of that output based on that query. Now, let's take that one step further. Let's go ahead and clear this out. And let's build on that. So we're going to keep the majority of the syntax of the command just like we had for the previous one. But now we're going to add an additional line here, the project operator. Think of project as saying, when I teach these courses, I say, think of project as show me. So in this scenario, based on the output, only show me the process and starting directories. Now it's going to generate an error because of our time. So I'm going to go ahead and remove the time field. Let's go ahead and run it. And here we go. So notice in the previous command, it gave us a bunch of rows and or a bunch of columns here. But in this one, I said, only show me these two columns, process and my starting directory. So the project command gives you the ability to limit what is seen. Now, the project command comes in many different options. To give you another example here, so we're going to use the same command, but now instead of using project, we're going to use project away. And I'm going to remove the timestamp again from here, and we're going to go back a few months to generate some data. Now, the project away command, as you'll see here in a second, what it does is it shows me every column except. So project away says show me everything except for process name. So if I scroll across here, you'll notice there's a process, but no process name column. So project means show me. Project away means show me everything except for. So that is the difference between those two commands. So now let's go into some additional ones. The next one we're going to look at is what we refer to as the summarize operator. So what the summarize operator allows us to do is to do that, exactly generate summaries. So we're going to look at the security event table. We're going to look again, our time frame within the last 7 days with the event ID 4688. But then we have this summarize by count. So what the summarize by count does is it aggregates the filtered data. So it's going to take line 2's filtered data and it's going to aggregate it. And it's going to group it based on process and computer. So it's going to count it and then it's going to group it based off of those. Now, I'm going to remove the time generated again because we want to generate some data here. I'm going to go back a few months here. We're going to apply this and let's go ahead and run this here. So you'll see here, we're filtering based on event ID 4688. So all of this is going to be related to 4688. I want to summarize count. That's what this is. It's a summary. Versus seeing each individual instance, if I didn't use summarize count, it would show me 633 rows of this. It would show me 1,200 rows of that. But no, I just want a summary of how many instances there are. And then if you notice here, I said count based on process and computer. Process and computer. So it showed me those two columns as part of that there. So to give you another example of how we can do this, let's do it. We're going to use the summarize command again, but now we're going to change it up a little bit. So now we're going to use the summarize command without count in this case here. Again, we're going to look at the security event table. We're looking for anything within the last 7 days, and we're using summarize. So what's going to happen in this scenario is the line is going to aggregate the filtered data by calculating decount. Decount is distinct count. So what I'm saying here is show me all distinct, how many unique IP address entries do we have? So how many different IP address entries do we have, in this case, within the last 7 days? But again, I'm going to remove this. Let's change this. We're going to go back a few months again. And let's go ahead and run it. So you'll see here, it came back and it showed me there's a total of 26 unique IP addresses over the time frame that I perform my query. So that's the D count. Think of D count as unique instances of that command. Now, the next command I want to show you, again, we're still in summarize here, is summarize arg min and summarize arg max. So we're going to start with the arg max first. And again, we're looking at the security event table. Within the security event table, we are looking for a specific device. Notice here equal. So we're looking for this specific computer in this case here. And once we filter and find that, I want to generate a summary of this. So what this is going to do, when I do a summarize arg max, it's going to go in and return the row with the lowest, which is max, time generated timestamp. And it's going to be by, in this case, the computer column or computer group. If I didn't specify a specific, ID like computer, I could put in an asterisk, which would do it for everything. But in this case, I'm saying only do it based on our computers. I'm going to, so let's go ahead and run this command. Here we go. So what you'll see here is we're only looking for this instance, which is my computer account, which is what you see right there. And then show me the argmax, which is basically the latest timestamp that I have for this device, which is this one right here, the latest and greatest. And of course, we're going to do it based on the computer column. Now, I can change this up, and instead of doing an argmax, I could actually do an arg minimum. And we're going to do the same thing. Where max, think of max as recent. Think of arg minimum as oldest. So what is the oldest entry that we have within here based on the computer column? So there it is. So it's showing us, it's not showing us every instance of this column. It's only showing us the oldest or the newest of those columns. So that's what the summarize operator, and there are many more options that you can have for summarize. Now, the next option we're going to do, or the next operator we're going to do, is summarize make list. Like I mentioned, there's quite a few different ones that we can do for summarize. When we look at the summarize make list command, again, we're looking at the table security event. We're adding two filter statements here. We're going to filter based on a time range and based on the event ID. And then what we want to do, the fourth line that we're looking at here is we're going to group the filtered events. And we're going to group the filtered events by computer. So we're going to summarize make list is we're going to group the filtered events by computer. And for each computer, what will happen is it'll create a list of account values, user accounts that logged in. And then the make underscore list account aggregates all the account names into a list for each computer. So let's take a look at that. I'm going to remove again, as we've been doing the time field, just so we can get some valid information. Let's go ahead and run this. And we don't have anything for the last 24 hours. Let's go back a while here and rerun it. And here you go. So in this scenario, we're looking at the security event table, and we're looking for event ID 4624. So we're filtering. So everything related here is related to event ID 4624. And then we're going to create a list. So the list is going to be based off the account and by computer. And you can see that right here. So it gives you all the details that you need. So that is your summarize make list. So what it does is it queries a list of user accounts that successfully basically logged in, which is event ID 4624 on each computer in the last in this case, custom range. By default, we had it for 7 days, but we're going to do custom. So for over the last few months, and then presents them based on a group by a computer. So that is your summarize make list. Now, the second command that we have is summarize make set. So let's take a look at that command. So when we look at the make list versus make set, so here's the key difference between the two. And the key difference between them is that the make set creates a distinct set of accounts that logged into each computer, whereas make list, it will also include duplicates. So where make list says, okay, give me every instance, make set says only give me unique instances on based on our query here. So here you see. So that is the main difference between those two commands. So just to reiterate, when you make a set, it creates a distinct set of accounts that logged into the computer, whereas make a list, it does the same command or the same output, except for it does not remove duplicates. It will include all the duplicates. So if you do a make set, then it ensures that only accounts appear once per computer, and based on the command that we're running here. So that's the main difference between make list and make set. Make set is unique entries. Make list is every entry that we have, including duplicates. Now, the final few commands that we'll look at is dealing again with the output. How do I want the output formatted for my query? So the first command, we're going to remove the time field here again. So what we're going to use here is what's called the render operator. And the render operator basically will generate an output that is in some type of chart typically, or an image. So let me give you an example. So here we're looking at the security event table. We're doing a summarize count based on the account field, and I'm going to see this in a bar chart. So let's go ahead and run this here. By the way, I want to point out something here, and I did this unintentionally, but it's a great thing to look at here. Notice the error that I'm getting here, saying that the table operator failed to resolve table expression name bar chart. And now my command is valid. Here's the problem. I actually highlighted part of the query, and I highlighted just the bar chart. If you highlight within KQL, it only runs what's highlighted. So it was an incomplete command. So what I'm going to do is I'm going to go in, I'm going to unhighlight bar chart and run the entire thing. And you'll notice now it generated a result. In this case here, it generated a bar chart based off of that information. Just to demonstrate that error again, if I go in and I highlight a specific portion of it and I try to run it, it'll generate an error. So you got to be careful when you're working with KQL to make sure nothing's highlighted. But there may be instances where you may want, I'll give you an example. Let's say I want to run the security event along with the summarize. Notice I now have the table and the first line highlighted, and it actually generated a result, but it didn't show my bar chart. So that's where so now I'm going to just highlight everything, and you'll see that I get the entire output here. So that's one example. Another example of using the render command would be the time chart option. So we're going to remove the time field here just so we can generate some data here. Let's go ahead and run that. And now you'll see a time chart. So there are many different options that you have when it comes to doing this. Now, the next thing I want to look at here, and we're getting close to the end here, is what's called the union operator. Now, the union operator allows you to take or merge or retrieve data in your query from more than one table. everything that I've done so far in this demonstration has been just one table, the security event. But now I can use the union operator to actually, in this case here, what's going to happen is we're going to pull all the data from security event and all the data from the sign-in logs, and let's go ahead and run that there. You got to make sure there's a space between them. So the output of that, as you can see here at the bottom, is basically all the columns from both of those tables within there. And with the union operator, there's many different variations that you can run this command if you want to. I can do it this way, which is saying union any table that starts with app. So now I'm saying, give me the data for all tables that start with app. And in this case here, notice here I did a summarize by count by type field. So here's my type field. And for app events, I've got 345,000 count entries in there. For app page views, there's 518,000 and so forth. But the key here is I'm pulling data from all tables that start with APP, as you can see here. So those are examples of how you can do the union command. If you want, you do also have the ability. So one of the nice features of KQL is the fact that you can extract data from your logs. And you can use the print operator to do that. So in this case here, print, and in this, I want to extract certain data that equals to 45.6. So in this case, we were looking for 45.6. Let's go ahead and run this here. And then here you go. So this is my output based off of that query that I want. So I can do a print operator if I want to as part of that. So there are many different options that we have when it comes to running KQL queries. So hopefully you've enjoyed this video, and the key to KQL is always practice. Luckily, KQL is very intuitive because as you start typing, it will give you examples or the next possible options as part of your query, your syntax, and so forth. So it's very intuitive. It does take practice. I would recommend there are some great sites out there that you can use for KQL tutorials. One of the great ones is if you go to Microsoft Learn. Here you go. This will be the overview page, but it walks you through. There's a nice quick reference guide for some of the most popular, conditions, operators that are out there, like the search one we've talked about. We talked about the where operator. We talked about the go operator. We've talked about the project. We just finished the print one. So there's many different operators out there. So I would highly recommend that you go to the Microsoft Learn site to get that, because KQL is very important. If you're going to be doing any type of log analysis, if you're going to be holding a position or you need to be able to perform those type of capabilities, you will need to know KQL in order to be able to be successful in doing it. So if you're, let's say, a security operations analyst or an engineer, or you're generating reports, understanding KQL will be a valuable tool in your tool belt there. Thank you very much, and good luck in your learning.
So this concludes Learning Path 6. In this learning path, we covered KQL statements. We talked about how to construct those KQL statements. We talked about various KQL operators such as summarize and render, union, extend, and so forth. We talked about KQL data extraction, how we can extract unstructured and structured data with KQL queries. We also talked about KQL functions, how to create KQL functions and parsers using KQL. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic in Microsoft Learn. And you can go there at aka.ms.learn. Thank you.